Today we will learn about Marshall stability test. This is also again one of the important tests on bitumen. Mississippi State Highway Department has found out this test and named it as Marshall stability test. This is the flow test on bitumen and is applicable to hot mix design of bitumen and aggregates of maximum size 2.5 cm. Bituminous concrete mix is commonly designed by Marshall method. This is very important. Bituminous concrete mix is commonly designed by using Marshall stability method. The stability of the mix is defined as the maximum load carried by a compacted specimen at a standard temperature of 600 centigrade. The flow is measured as the deformation in unit of 0.25 mm between no load and maximum carried load by a specimen during stability test. This test attempts to get the optimum binder contents for the aggregate mix type and traffic intensity. This is the test which helps us to draw the Marshall stability versus percentage bitumen. So this is the apparatus used called as a Marshall stability test apparatus. Again there will be requirement of the cylindrical molds, stamping rods, hammer. So this is the procedure for the Marshall stability test or flow test on bitumen. The specimen mold assembly comprising the mold cylinder of 10.16 cm diameter and 6.35 cm height with base plate and extension collar. So here at the bottom you can see here there is a mold along with the collar and base plate is provided. Specimen extractor for extracting the compacted specimen from the mold is required. Okay, a specimen bar is required to transfer the load from the extension collar to the upper providing ring attachment while extracting the specimen. This entire procedure we are going to do it in the transportation laboratory. The compaction hammer having a flat circular tamping face 4.6 mm sliding weight constructed to provide a free fall of 45 cm. Compaction pedestal consisting of 20 by 20 by 45 cm wooden block capped with 30 by 30 by 2.5 cm MS plate to hold the mold assembly in position during the compaction. Mold holder is provided consisting of spring tension device designed to hold compaction mold in place on compaction pedestal. Breaking head. This consists of upper and lower cylindrical segments or test heads having an inside radius curvature of 5 cm. The longer segment is mounted on a base having perpendicular guide rods which facilitates the insertion of the holes of the upper test segments. Now loading machine, we have to apply load. It is provided with a gear system to lift in the upward direction. The pre-calibrated proving ring of 5 tons capacity is fixed on the upper end of the machine. Specimen contained in the test head is placed in between the base and the proving ring. The load jack produces a uniform vertical movement of 5 cm per minute. The machine is capable of reversing its movement downward also. This facilitates the adequate space for placing test head system after one specimen has been tested. Flow meter consists of the guide, sieve and gauge. The activating pin of the gauge slides inside the guide sleeve with a slight amount of frictional resistance. Least count of 0.02 mm is adequate for this, and the flow value refers to the total vertical upward movement from the initial position at zero load to value at maximum load. The dial gauge of the flow meter should be able to measure accurately the total vertical movement upward. So, what should be the sample? How it should be? There are two grades: percentage passing by weight. So these are the sieve sizes given and how much should be the weight taken. This is all specified gradation. So total percentage by weight of a mix for grade 1 it should be between 5 to 7.5, and if you take for grade 2 it should be 5 to 7.5. But for grade 1 for 20 sieve size you don't have to take any sample by weight, and for next you have to go on taking this weight. Whatever will be the percentage passing, these weights are given to you. The average value of each of the above properties are found for each mix with the different bitumen contents. These 5 types of graphs are plotted with the bitumen contents on x-axis and the following values on y-axis. So x-axis will be the percentage bitumen, this will be constant, whereas y-axis will differ and you have to plot these 5 graphs. On y-axis you have to plot Marshall stability value, then flow value for the second. For third graph there will be unit weight on y-axis. For fourth graph there will be percentage voids in total mix, that is VV, on y-axis, and for fifth one percentage voids filled with bitumen on y-axis. So this all gives you the bituminous mix designed by Marshall stability test. So all the contents of this unit number 4 were taken from Justo and Khanna book, that is Highway Engineering, and some IRC codes as we suggested. Some of the tests these were taken from that specified IRC codes. So here we have almost finished unit number 4 also, and so if you have any doubts you can always ask. So we will stop here. Thank you.